This episode,
We have liftoff.
a Delta rocket heads sky high, but then
We have had an anomaly.
This rocket was very unusual that it exploded in the first few seconds when it was close to the ground.
and now, toxic flames are falling everywhere.
Three, two, one. We have ignition and liftoff from Cape Canaveral Air Station.
This 12-story high Air Force Delta II rocket is carrying a new $40 million GPS satellite into orbit, but it won't get far.
We have had an anomaly.
In a terrific blast, 1,200 feet over ground, the 250-ton rocket explodes into flaming fragments. Newspaper photographer Rick Jesse was shooting the event from a mile away, but he's forced to run for his life.
All broke loose. The sky was completely covered with debris. As I dropped the camera to turn to run, you could hear debris coming towards us. It sounded like incoming mortar rounds on a grade B movie.
Massive chunks from the solid fuel boosters, burning at 1,200 degrees, rain down in a lethal pyrotechnic display. San Diego Air and Space Museum director Francis French has witnessed many launches, but nothing like this.
Most times rockets go wrong. They're a long way up. This rocket was very unusual that it exploded in the first few seconds when it was close to the ground, and that can be potentially a lot more dangerous to people.
A few miles away, the 8,000 residents of Cape Canaveral could be facing deadly consequences from this launch gone wrong.
They advised everybody to stay indoors, to close their windows, to turn off their air conditioning systems.
The Delta II is a 3-stage rocket powered mostly by 10,000 gallons of kerosene and liquid oxygen in its main booster.
When you get into the second and third stages, there's some very strange exotic fuels being used there, and those are not good for you. They could get into your eyes, they could irritate your skin, and you definitely don't want them in your lungs.
The trouble began with one of the 9 solid fuel boosters at the bottom of the rocket.
On the outside, they put some solid rockets just like this one, and they strapped it essentially just like this to the outside to help give it an extra boost. Essentially, you have all your propellant inside. There's a mixture of fuel and oxidizer already in there, made in a kind of paste. When you light the center of it, it will burn to the outside in a very, very regular way.
Investigators found that one of the boosters had been slightly damaged on the ground before it was attached to the rocket. The booster is about 30 feet long, 3 feet in diameter, and weighs 28,000 pounds. Gases from the solid burning fuel amount to 1,000 pounds per square inch of pressure. Under that kind of stress, any defect will be exploited.
The trouble is, if something goes wrong with this, if, for example, it got a crack along the side of it, at that point, the flames would come out of it and it would go off course. So this is very precisely designed, but it could also go horribly wrong.
The misguided thrust of the damaged booster could even cause the rocket to tumble in midair and crash to Earth. But instead, the Delta II is programmed to self-destruct the moment it detects a sudden change in direction. Engineers on the ground detonate the remaining stages by remote control, avoiding any chance of large debris and fuel falling into populated areas. The damage on the ground from the burning solid fuel boosters is extensive. Cars and buildings on the base are burnt to cinders. Photographer Rick Jesse and his fellow journalists are safe inside a protected bunker.
The explosion started a number of fires in the area. They had to be dealt with. The Air Force was making sure we were safe, and I appreciate that.
But danger still lurks in the air, because now, for thousands of residents in towns surrounding Cape Canaveral, those massive wind-blown fumes created by the explosion could spell disaster. Rocket engineer Doug Jones knows the dangers well.
The most troublesome propellants on board are in the second stage, the hydrazine and the nitrogen tetroxide. It's mutagenic, it'll cause birth defects. The nitrogen tetroxide is kind of like nitric acid. It's about as dangerous as the chlorine gas that was used as a poison during World War I.
We have ignition ignition and liftoff.
A Delta II rocket carrying a GPS satellite into space explodes seconds after liftoff at Cape Canaveral, Florida. Flaming fragments of the solid rocket boosters fall to the ground like a torrential meteor shower.
When it blew up at 1,600 feet, you didn't know at the time how far it was going to travel. And there were some large pieces of rocket headed our way. Some of the pieces were as large as cars.
Photojournalist Rick Jesse flees to the Mission Control Center to escape the danger. But the debris takes a heavy toll on cars and buildings near the launch pad, and a threat still hangs in the air.
The Air Force was worried about toxic fumes in the area and which way they were going to travel. I believe there were 2 actual clouds of gas that formed.
The nitrogen tetroxide for the upper stage is about 4 tons of a gas that's about as toxic as chlorine that was used as a poison gas in World War I.
The Delta II rocket has a reliable record with 135 successful launches, including 75 in a row without incident. But when a rocket launch fails, there is little choice but to abort and destroy it and the payload, costing tens of millions of dollars and years of hard work and planning.
It took years for them to build one of these satellites, and then in a second, it's gone. It's a real tough, heartbreaking thing to see. But this is the nature of space exploration.
Someday, there may be an alternative. Engineers like Doug Jones at X-Corp Aerospace in California are working hard on a rocket called the Lynx Mark II, with plans to fly passengers into outer space.
Our vehicles take off horizontally, and that allows you to have multiple redundant abort options so that if any time you have a systems failure, you can either land straight ahead or you can land on another runway later on. When we improve the vehicle, make the tanks lighter and slightly higher thrust on the engines, we'll be able to reach 100 kilometers altitude, which is the international definition of space flight.
For now, big vertical liftoff rockets like the Delta II are still the way to go for heavy payloads. But this rare low-level explosion challenges every contingency plan on the books. Randy Evans is a consulting meteorologist at the launch.
The lower plume was the result of the actual Delta explosion. The upper part of the plume is from the stage 2 and stage 3.
Predicting the weather for every rocket launch is critical and could mean the difference between life and death, based on the smallest changes in wind direction. And the Air Force has plenty of tools at its command.
The RAMS model is the Regional Atmospheric Modeling System, and it forecasts what the wind directions, wind speeds are going to be.
Prior to every rocket launch, meteorologists use the RAMS system to predict the wind speeds and direction during liftoff. They need to be sure that winds in the lower and upper atmosphere are moving away from densely populated areas. If not, the mission is scrubbed for another day.
What it forecasted was, at about 800 meters above the ground, the winds were generally from the northeast, and then later, even 2.5 hours later, the winds shifted more and they were even more coming more from the northeast.
The Delta II mishap is challenging because there are 2 separate explosions. The first, when the lower stage of the rocket self-destructs after the booster fails, and the second, when ground control detonates the remaining upper stages. The explosions leave 2 plumes, one laden with toxic fumes at over 800 feet, moving with warm winds, and a larger plume beneath, from over 30 tons of kerosene fuel moving inland.
A few minutes after the rocket exploded, there was an initial signature on the NEXRAD Doppler radar of the initial plume. This was approximately 30 minutes after the explosion occurred, about the time that the plume was coming ashore between Patrick Air Force Base and Cocoa Beach.
Luckily, for close to 30,000 residents on the ground, there's some good news.
It was primarily the rocket fuel kerosene that dispersed into very low concentrations.
Fallout from the kerosene plume dispersing over land is far less dangerous than that of the higher toxic cloud.
The upper part of the plume was generated when the stage 2 and stage 3 part of the rocket was exploded, and that was at a higher level, at approximately 1,200 to 2,000 meters above the ground. The stage 2 actually contains some N2O4, which is nitrogen tetroxide, which is a more dangerous material.
But fortunately, upper atmospheric winds are blowing the smaller, more dangerous plume straight out to sea.
The strong winds were from the west there, and it blew the thing out towards the east.
It's not by accident that a disaster was avoided. Weather forecasters have the daunting task of making accurate atmospheric predictions, or many lives could be at risk.
It was highly fortunate no one was in there.
Photographer Rick Jesse is certainly grateful, and also happy his camera lens was focused on the action.
I was lucky enough to get one photo of the explosion that showed the nose cone intact, which basically proved that the payload was not at fault for the explosion.